I work as a visiting lecturer at Government College of Technology, Swat. I also worked as a visiting lecturer at UT Peshawar, and I also worked as a research associate under your supervision. Um, Currently, I'm doing a master from UT Peshawar in Technical Engineering. Uh, so that is,
What makes you choose the geotechnical engineering? Why not other fields of the civil engineering?
sir. I think when I was in undergraduate, um, I was thinking that there are more situation in the structure side. Why not go to the other field like geotechnical engineering, where I think there are no such expertise in geotechnical related expertise in even our university, and if we look in the country, so there are no geotechnical expertise or geotechnical engineer available. So I was thinking, why not go to this field and let's have some good research and some good publications, and let's try our luck in geotechnical engineering.
Okay, thank you very much. Atif,
Yes, sir.
so please
My
a
name is
brief intro about yourself, where you are currently working, when you graduated, what makes you choose the geotechnical engineering?
my name is Muhammad Atif Hussain. Currently, I am working in Islamabad as a project inspector. I am here with the builders, the contractors. They are contracting, taking plots, building the projects, and then selling them. And I have done my BS Civil Engineering from UT Peshawar in the year 2019. And I have choose geotechnical engineering because there is no much specialization in this field. We are mostly
Okay, Shahid Ali Khan. Shahid Ali Khan, can you hear me?
sorry, sir. I have some technical internet issues. That's why I have.
No worries. Everyone is facing that pandemic COVID-19 situation, so the connectivity issues are there. I know. I am also connected to via the cell phone internet. So sometimes it works, sometimes it won't. So if the screen is not visible or if the voice is not clear, please give me a call. Those who is having my cell phone number, just give me a call, one person, then I will rejoin. Hopefully that issue will be resolved as well. Okay, so Halimullah Khan.
Assalamu alaikum, sir.
Wa alaikum salam.
My name is Engineer Halimul Lahan. I basically belongs to Bannu. I have done my graduation from UT Peshawar in 2019. Since then, I am working as a lab engineer at Abbasi University Peshawar. This is my second semester in Master in Geotechnical Engineering. My motivation behind geotechnical engineering comes out from my final year project, where we use Plex study software in comparing different types of foundation. It was very interesting to know to come to look for the behavior of soil under the application of load. So since then, my interest was in geotechnical engineering.
Okay, thank you. Shahid, welcome again.
Thank you, sir. Assalamu alaikum, sir.
Wa alaikum salam.
Sir, I am Shahid Ali Khan and I did Bachelor of Science in Civil Engineering from UT Peshawar in 2019. Now it's my second semester of enrollment in MS, Geotechnical Engineering, and since my graduation, I am doing job as a research assistant with Professor Dr. Irshad Ali.
Good. So why you chosen the geotechnical engineering?
Sir,
Why not?
actually,
Yes.
it was my interest from the first semester because you can see that maximum type of failures or problems you will see on the site are related to geotechnical engineering, and the whole scenario first of all starts from the foundation. So that's why I want to get more insight in this field.
much, Kifayat.
सर आपकी आवाज़ कट रही है.
Yes, thank you very much, Kifayat.
Thank you.
Assalamu sir.
Walaikum salam.
My name is Kifayatullah. I did my BC from UT Lahore. Then I go to Dubai for work there. I did their job for almost 2 years. Then I returned back here to Pakistan. And nowadays I am working here as a lecturer at GPC Karak. And my motivation about geotechnical engineering was due to my experience there at Dubai. I worked there at certain projects like hardscaping, softscaping. That's why I choose geotechnical engineer as my MSc subject.
So,
Geotech.
what is hardscaping and what is softscaping? So, we learned about the soft skills, but we never heard about the soft scaping and hardscaping. So, could you please elaborate a little bit? What does it means?
So we did the job. We have the playgrounds. We did there the making of playgrounds and other types of work like uh, we make the here planting trees. We did there some work for these plants.
Okay, what type of geotechnical projects were
Hello,
conducted at Dubai?
what's that?
What kind of projects you worked on apart from the landscaping issues? What kind of project you worked on related to geotechnical engineering?
Sir, there was one of our project was about the ground situation. Like one of the plaza was built there. No, I was there, although I was only a junior engineer there. But at the start of the work, I was there. That's why I choose the geotechnical engineering.
Okay, thank you very much. Sumer, please.
Assalamu alaikum, sir.
Wa alaikum salam.
Sir, my name is Muhammad Sumer and I am from Peshawar. In fact, my insist was from Lucky Marad, but now we are living in Peshawar. I had completed my BS from UT Peshawar. Along with MS, I also engrossed in various kind of competitive exam and also engrossed in social activities. In fact, UT intrigued me when I was in second semester. That's why I take admission in geotechnical engineering. Hello, sir. Hello.
Okay. Wahidul Wakar Yunus, sorry.
Assalamu alaikum everyone. My
Wa
name
alaikum
is
salam.
Sayyid Wakar Yunus. I completed my graduation from UT Peshawar in 2016. My graduation research thesis topic is base isolation for building using rubberized concrete pads. After that, I started tech admission in MS in UT Peshawar with specialization in earthquake engineering. I completed it in 2019, where my research thesis topic is seismic characterization of Peshawar region using ambient noise, where I studied the different dynamic properties of soil, resonance frequency of soil, and I developed a resonance match for district Peshawar. Sir, can you hear me?
It's a bit weaker, the voice is a bit weaker, but I heard about the dynamic properties of the soils.
Yes, sir. Dynamic properties of soil. Now, sir, I am PhD scholar here. My research topic is ground motion prediction equation for Pakistan. Its development. And now I take this subject in order to know about the soil parameters, that is soil potential, soil resistivity, classification of soil, moisture content, and pH table related to these qualities. And the dynamic properties that I talk about it, sir, in my ambient noise, I faces two types of disturbance. One is natural disturbance, the other is anthropogenic disturbance. Now I need to know which dynamic properties are involved in the disturbance and in the natural and anthropogenic disturbance and that create different stresses which disturb that ambient nature.
Okay, okay. Thank you very much. Yep. Wahid.
Assalamu alaikum, sir. Hello.
Yes, please introduce yourself.
Yes, sir. My name is Wahidullah. I am basically from Parachinar Agency, and I completed my graduation from UT Lahore in 2011. And after working with different companies, I have been enrolled in Earthing Engineering Department in March 2018.
Okay, thank you very much, everyone. Now we will go through the course outlines, which we are going to study during our advanced soil mechanics course. So we are having a textbook here, which will be the Buddu's 2010 Soil Mechanics and Foundations third edition. There are other suggested books, which are Holtz and Kovics, Sheehan 2011, An Introduction to Geotechnical Engineering. Wood, David Muir Wood wrote a book in 1991 related to the soil behavior and critical state soil mechanics. It's a very interesting book on the soil behavior and the constitutive modeling. Basically, the idea of critical state soil mechanics and soil modeling started with Schofield and Roth at Cambridge University when they developed the CAM clay model. So this is a very important book related to the second part of this course, which is related to the critical state soil mechanics. Now the course aims, the broader aims in this course would be understanding the advanced concepts which are presented here and which are necessary for a graduate student to understand. First of all, the teaching learning activities will be a series of lectures, laboratory assignments, coursework assignments, self-study material, and a term project will also be given to the students. Now, all these activities are done to understand the fundamental aspects of stress-strain response, to study the constitutive concepts related to the soil modeling, and to expose the student to various advanced lab and field tests to find the strength of the soils and to find the stress-strain behavior. Also, it will give you an idea that how you interpret those data to get the necessary soil parameters. We may present few case studies and their applications related to the geotechnical engineering design, and we will move towards the elasticity and plasticity theories, shear strength, stress paths, lab and in situ measurements for determining the soil properties, basic constitutive models, critical state soil mechanics, and applied soil mechanics will be discussed at the later part of this course. Now, on completion of this course, students are expected to have the knowledge and skills to understand the advanced lab testing, shear strength, stress path behavior, and constitutive modeling and its applications, practically how it can be used to analyze the geotechnical infrastructures. In the first week, which is today, we are going to introduce the course related to the shear strength of the soil. We will discuss the typical response of soils to shearing forces, and we will also study the applications of shear strength. There are different effects. For example, the normal effective stress, the effect of OCR, effect of drainage of the excess pore water pressure, effects of cohesion, effect of soil suction, and the effects of cementation will be discussed in today's lecture. Then in the next week, we'll discuss the laboratory test to determine the shear strength parameters, simple shear test to find out the friction angle of clean and coarse grained soils, shear box or the direct shear test, conventional triaxial apparatus, unconfined compressive strength, consolidated drained and undrained and unconsolidated undrained test will be discussed in the second week. Then we will talk about the pore pressure parameters. We will also discuss few other advanced apparatuses which are used to find out the properties of the soil. Now we will solve few examples related to these types of tests which we study in the fourth week. Then we will move towards the field tests which are performed to find out the shear strength parameters and various geotechnical parameters important for geotechnical engineers. We'll solve few examples, problems on the field test, and then we will move towards the very interesting topic and very advanced topic related to the critical state soil mechanics. Introduction, basic concepts, parameter mapping, failure surfaces, soil yielding, prediction of the behavior of different types of soils, NC, clays, or over-consolidated soils under different loading conditions like drained and undrained conditions. Prediction of the behavior of different types of soils will be discussed under drained and undrained conditions. Elements of the critical state model, yield surfaces, critical state parameters, failure lines in the P prime and void ratio space, failure stresses in the critical state model, drained triaxial test and undrained triaxial test will be discussed in the 8th week of this lecture. Then we will move towards the midterm, which is basically the, I guess, 20% of your course. Modifications of the critical state soil mechanics and their practical applications will be discussed after the midterm. Relationship between different parameters, different normalized parameters will be discussed in the 11th week. Soil stiffnesses from and strains from the critical state model, volumetric strains, shear strains, strain response, and application of the critical state soil mechanics to cemented soils will be discussed in the 12th week. Examples and problems related to the critical state soil mechanics will be solved in the 13th week. Cam clay and modifying cam clay, which was proposed by the Scaffold and Roth and Russo, respectively, stress path behavior will be discussed in week number 14. In 15th week, application of elastic plastic constitutive models. And at the end of this course, we will be having our presentations of the term project and presentation of the term project in the 17th week as well. The grading policy, we will be having approximately 3 quizzes here and 3 assignments, I guess, here. And term project 1, midterm is 1, and final term 1, so it will be 100% for us. Now, starting with the shear strength of the soils. So there are few slides or few concepts which you might have already learned during the Geotech 2 undergraduate course. So we will go because it's just like an introductory lecture today. But still, we need to answer a few questions related to the shear strength of the soils. That how we determine the shear strength of the soils, what is the difference between the drained and undrained shear strength, why we study shear strength, what are different types of shear strength test to simulate field conditions, lab and field test results to obtain shear strength parameters. So let's start. What is shear strength in your mind and why we study it and how we determine the shear strength? What is shear strength of soil? Where we use shear strength of soil, how we determine the shear strength of soil.
Sir,
A short discussion is requested here.
जी sir. Sir, maximum stress that a soil can experience without failure. We call this shear strength. Sir, we use these parameters in the bearing capacity, retaining walls designs, stability of slopes, and embankment, etc. Sir.
Can you hear me? Please confirm that you can hear me and the voice is clear.
Yes, sir, clear.
Okay. So why we study shear strength? Where we use shear strength and how we determine the shear strength. Anyone?
Sir, I told you earlier, sir. Can you hear that or not?
Yes, please.
Sir, shear strength is the maximum strength that a soil can experience without failure, sir. This is
Okay.
basically a critical parameter. We can use it in the to derive bearing capacity and the design of retaining wall, stability of slope, and embankment, sir.
Okay, and how we usually determine the shear strength of the soil. Thank you very much, Wakar, for your participation in the discussion. Anyone?
Sir,
Yes, please.
we can determine it by using a borehole test, sir, direct shear stress, triaxial test, VST test.
Okay, what a structural engineer wants from a geotechnical engineer. So structural engineers needs to construct or design a structural a building there or a plaza there. So what he needs from a geotechnical engineer? What kind of information is needed from us?
Sir, basically, a structure engineer didn't know about the site effects of the soil and the dynamic properties of the soil, sir.
Okay.
Sir, they got these dynamic properties from a geotechnical engineer. For example, sir, bearing capacity. Sir, they
Okay.
didn't know how to calculate and which value is used and which type of class soil class is here, sir. That's why they got that information from geotechnical engineer.
So excellent. First of all, let me go here. So if I say in the step number 1, bearing capacity, I would call that as allowable bearing capacity. So they want from us the bearing capacity. Now, how we calculate the bearing capacity? What are the theories which you remember?
Terzaghi, sir. Terzaghi equation.
Okay, so we have Terzaghi's bearing capacity equation. We also have the Meyerhof bearing capacity equations. Now, in these equations, what we use?
Sir, we use cohesion and internal reflection of soil.
So basically what Fahim is saying that we use shear strength parameters in those equations, right? And these equations are C and phi. Now, how we calculate or determine those shear strength parameters?
सर लैब टेस्ट से हम shear strength parameters जो हमारे पास है वो कैलकुलेट कर सकते हैं सर.
Excellent. Now the next question comes in our mind. Let me go for this one here, lab test. Okay, what kind of lab test? I would call that as 5. What kind of lab test will give us that C and phi?
सर डायरेक्ट shear test के थ्रू हम
Okay,
फाइंड कर सकते हैं.
direct shear test,
और सबसे इम्पोर्टेंट ट्राई एक्सियल जो हमारे पास है जिसके थ्रू हम फाइंड कर सकते
triaxial. Okay. Now, what else? Now in direct shear, what are the advantages to find out the, I think so black is good. Okay. Advantages and disadvantages of the direct shear test.
Sir, advantage is that it is a very simple test and we can perform it very easily with a low cost.
Good. Okay. And the disadvantage?
Sir, here we have a predefined failure plan, so the soil do not fail at natural or critical line.
Okay, it's like predefined failure plane. And for
और
the triaxial?
सर डायरेक्ट शेयर में हमारे पास मतलब डिफरेंट फैसिलिटीज भी नहीं हो सकती कि हमारे पास कंसोलिडेटेड अनड्रेन्ड है या ड्रेन
Okay, so
टेस्ट
the drainage is also an issue.
जी सर.
And how
और
about the triaxial?
ट्राइक्सल में सर टाइम बहुत ज़्यादा मतलब क्योंकि वो ऑलमोस्ट नेचुरली इस तरह सोइल एक्चुअली बिहेव करता है इस तरह वहाँ पर वो उसकी हम बिहेवियर को चेक करते हैं तो ये टाइम लॉन्ग टाइम के लिए सर होता है और
Okay,
बहुत
so
एक्सपेंसिव भी है.
I would say that we can control drainage.
ड्रेनेज भी कंट्रोल कर सकते हैं.
Yeah, drainage control is here. So it's better to use this one compared to the direct shear test. And weakest plan, I would call that. weakest plan, we can get the failure. Still, if we see here, what's going here? Now we don't know which test we performed, and we already know that we have lots of different types of triaxial tests. For example, CD, CU, UU. Now, from which test we got these shear strength parameters, and who is using into these equations, and who is giving the Q allowable to a structural engineer. Do you think structural engineer thinks about that how you calculated the Q allowable? Which equation do you used for the calculation of the allowable bearing capacity? How you determine the shear strength parameters? What type of lab test you performed during for finding the shear strength parameters? How about the direct shear test? And how about the triaxial test? What type of triaxial test you performed during the shear strength determination? The story is not finished yet. I would say this will be 6 here. So this color was good. So in the 6th point, who did the sample preparation? Type, what kind of sample preparation method was used to prepare the specimens in direct shear test or triaxial apparatus? Seventh, how the samples were transported. Okay, how the samples were transported to the lab, it also depends upon how you are going to get the shear strength parameters. Still, one thing is remaining. What is that? What is the last thing which we need to think about as a geotechnical engineer? Anyone? Just say one word or 2 words. Anyone? Kifayat, Sumer, Halim, Fahim, Shahid. Any idea? Please confirm that you can hear me and the screen is visible.
Yes, sir.
Okay, it's the
Yes, sir, the screen is visible.
sample collection. Okay, whether you perform the standard penetration test, you use shell by tubes to collect the samples, you use the split spoon sampler. So these are all the questions which will come into our mind from sample collection, that how the samples were transported. I usually give an example that if we are constructing a building in Abbottabad, how the sample collection was done, by whom the sample collection was done, how the samples were transported. Now, who did the sample preparation in running the lab tests, and what type of lab test you need to perform, and then the shear strength parameters will come into play. You will insert those values into the Terzaghi's bearing capacity or Meyerhof bearing capacity equations. Then you will get the Q allowable, and that one value you will give to a structural engineer that he will use in the designing of the foundations. So you can clearly see that the shear strength parameters are very, very important in design of the foundations. Now, what is the importance of the shear strength of soils? So the shear strength is required to make estimates of the load bearing capacity of soils and the stability of geotechnical structures in analyzing the stress strain characteristics of soils. You can see here houses are almost at the verge of the failure due to rainfall. You can clearly see that this area has suffered the landslide, and significant shear failure has occurred. So it's a significant loss, it's economic loss which has occurred to the houses. So therefore it's better to understand the shear strength behavior and the shear strength of the soil. Now, what is shear strength? It's the property that gives a soil the capability to support structural foundations. So for example, if you build a house here, now if it's stable, it means that the bearing capacity or the allowable bearing capacity is sufficient enough to hold this structure. But unfortunately, in this case, you can clearly see that the tilting has occurred, and we are having a shear failure here. Similarly, if we go for the embankments, it's important for the slope stability issues or the retaining walls. Shear strength is important property. As we know, soils usually fail by shear, and geotechnical engineers must therefore design the geotechnical structure such that the internal shear strength of the soil will not be exceeded, thus leading to failure and collapse. So you can clearly see a few examples in the embankments, plaza, multi-story buildings, slope stability issues will come into effect. Now the shear strength is dependent upon the material properties, and if you want to determine the shear strength, this will be the part of the course comprehensively application of the shear strength in bearing capacity equations, and all this can be used in finding the bearing capacity, landslide slope stability, and others, embankments, different types of geotechnical structures. Another importance of the shear strength parameters are the shear strength of the soils, are that different models, constitutive models, use shear strength parameters in different geotechnical softwares, for example, Pluxus, Bacchus, or GeoStudio. So you can clearly see that these parameters are used in Pluxus software here as well. So if you want to go for the hardening soil model, we will discuss these models in the constitutive modeling or the critical state soil mechanics part. You can see here cohesion, friction angle, and dilatancy. So cohesion, friction angle, dilatancy are used in various softwares. Now, in case of the GeoStudio, that you know that it's used mainly for the slope and seepage analysis. You can clearly see the cohesion and friction angle are used. Even the basic geotechnical properties are also used in finding the factor of safety against the shear failure. You might have seen these slip surfaces. So you give them the input values here, and then you will see a slip surface with having a certain factor of safety. These are the material properties which will be required in Fluxus software for analyzing a certain type of structure. So you can clearly see that shear strength parameters are present here. So that's why understanding the shear strength of the soil is important. Friction angle, if you want to use the Abacus software, it's powerful software. It's related to some structural components. You know, if you are designing structural components, it's better to design the structural components and apply different loading conditions and use advanced loading, advanced soil modeling. You can also add your model to this software. So cohesion, friction angles, or the shear strength parameters are also used in these softwares. Now, what are these applications? Applications definitely include analyzing the slope stability issues, and for shallow foundations, so you can see here that the shear stress is applied due to the shallow foundation, and in opposite direction the shear strength will be mobilized, which will be due to the cohesion and friction angle of the particular soil. Same in case of the inertial forces, or we can also say that the disturbing forces will occur due to the gravitational force, and shear strength of the soil will be mobilized along the slip surface or the failure surface in this way. In retaining wall and in tunnels, the concept of the shear strength is important to know. Even in the highway pavements or the pavement designs, the tires exert certain pressure on it. So you will also need the shear strength of the soil to hold that pressure which is exerted by the tires onto the soil. So the information about the cohesion and friction angle is important here as well. Now, the next question which comes in our mind would be, what are the factors which will affect the shear strength parameters? So let's have a short discussion here. Shahid, can you hear me?
यस सर, आवाज आ रही है proper?
Yes, sir.
To Halim.
जी सर.
Now, what are the factors which will affect the friction angle? We already
Friction.
know. Yeah,
Yes
we
sir.
already know, just to clarify here, that
सर फ्रिक्शन एंगल जो हमारे पास shear strength पैरामीटर्स है, तो उसमें सबसे इम्पोर्टेंट तो हमारी ड्रेनेज कंडीशन है. क्योंकि सर सॉइल की अगर कोहेजन है भी, तो वो भी अपेरेंट कोहेजन है, मतलब क्ले में अगर देख लें. क्योंकि अगर उसमें मतलब वो सेचुरेटेड हो जाती है, तो उसकी वो कोहेजन भी चली जाती है. इस तरह
okay.
सैंड में हमारे पास सर सैंड में भी उसका मतलब प्योर सैंड में तो कोहेजन हमारे पास जीरो होती है. लेकिन अगर हमारे पास उसमें मॉइस्चर आ जाता है, तो उसमें भी अप टू सम एक्सटेंट कोहेजन आ जाता है. और उसका जो एंगल ऑफ इंटरनल फ्रिक्शन है, वो वाटर की वजह से वो फिर कम होना स्टार्ट हो जाता है सैंड के केस में. तो
So
जो ड्रेनेज का
you want to say that the moisture
वाटर कंटेंट.
affects the friction angle,
यस
right?
सर. यस सर.
Okay. What a what's the other parameter, or what's the other factor which will affect the?
सर साइज ऑफ द पार्टिकल, सोइल पार्टिकल जो हमारे पास है.
Okay, that's good. Size of particles.
और सर शेप ऑफ द पार्टिकल, क्योंकि सर हमारे पास जितना रेगुलर शेप होगा, इतना ही
Shape
हमारे
of
पास
the.
सॉइल इंटरलॉकिंग ज्यादा
Okay,
होगी.
that would be the shape. Okay, what else? So we are talking about the friction angles so far. What is the other factor which will affect the friction angle? Shape, size, moisture. How about the density?
यस सर, उसका डेंसिटी बहुत इफेक्ट पड़ेगा यूनिट वेट ऑफ.
How about the void ratio?
यस सर.
Okay, how about the mineralogy? Different types of minerals can affect the friction angle as well. So all these factors will affect the friction angle. Let's see what we got here. Now, mineralogy will play a major role in affecting the friction angle. Now, different types of minerals, for example, quartz or mica. So for the quartz, you will have the higher friction angle, and for mica, it we will get smaller friction angles. Now, when we are dealing with the shape, so the rounded ones will have lesser friction angle. However, for the angular one, we will be having greater friction angle. For well-graded material, so what is a well-graded material? First of all, what is a well-graded material?
सर जिसमें हमारे पास आल साइज पार्टिकल हो.
Good. Okay, so those well-graded soil will be having more interlocking. Now, what is interlocking?
सर इंटरलॉकिंग की वजह से उनके दरमियान जो वाइड्स होंगी या ओपन स्पेसेस होंगी, वो कम होंगी सर.
Excellent. Okay, so
डेंसिटी
no
उनकी
need to
ज़्यादा
go.
होगी सर.
Okay, excellent. So for poorly graded, we will have lesser friction angle, but for well graded, we will be having greater friction angles. Now, decreasing the void ratio, which means we are compacting the soil, will increase the interlocking, and we already know that interlocking increases the friction angle. Now, organic material. The presence of organic material will decrease the friction angle. And why it will decrease the friction angle? What's the reason?
सर उसमें वॉल्यूम चेंजेस बहुत ज़्यादा फिर हो जाती है हमारे पास.
Volume changes. That could be the one reason, but I want to make it somewhere here. Let me put another thing here is the silt content. How the friction angle will be affected with the silt content, or we can say fine content.
डिक्रीज होगा सर फ्रैक्शन एंगल.
Okay, that's a good discussion. Why it will decrease? Why the friction angle will decrease? Why the friction angle will decrease? Why the friction angle will increase? Silt content.
सर डिक्रीज इस तरह करेगा सर क्योंकि फाइन कंटेंट जब भी हमारे पास ज़्यादा होते हैं तो वो जो फ्रैक्शन है सर वो मतलब जो स्लिप है सर उस मतलब एक होता है फ्रैक्शन एक होता है स्लिप होना सर. तो ये फाइन कंटेंट जो इनके दरमियान फ्रैक्शन है वो फ्रैक्शन को डिक्रीज करेंगे. मतलब वहाँ पे जो है एक पार्टिकल दूसरी पार्टिकल के ऊपर स्लिप आसानी से करेगा. तो जब भी कंटेंट हमारे पास फाइन कंटेंट इंक्रीज होंगे तो वो हमारे पास जो पार्टिकल टू पार्टिकल जो फ्रैक्शन है वो रिड्यूस होगा. तो इसके साथ जो है हमारा इंटरनल रिफ्रैक्शन भी कम हो जाएगा.
So let us have few particles here. So these are coarse grained particles. For example, this is placed in a container. So if I place, for example, approximately 5%, I guess, of the silt content, so these are very tiny particles, less than 1002 micron somewhere. So what do you think? This is going to change the frictional characteristics of the soil, or it will increase the frictional characteristics of the soil?
I think it will decrease.
The frictional characteristics. So research says that up to 5 to, for example, I guess 10% silt content don't change the frictional characteristic, or even it enhance the frictional characteristics of the soil. But if you go beyond that threshold percentage of the silt, what's going to happen here? Now you are having too many particles which will come in between these coarser particles, and these for example greater than, I would say, 10%, they will significantly reduces the frictional behavior of the soil. This is the research what it says. Lots of debate is still going on that what's going to happen. There are different thoughts on it. As Fahim is saying that it will reduce. So there are a few people they agree with that, but most of the research says that as these particles are very tiny and there are already voids present in between here, so these usually increase the density of the soil, and it will increase the shearing behavior initially for lower percentages of the silt content. Anyways, that is one thing which came into my mind, and I wanted to discuss that as well. Now for the cohesive strength, cementation, either we are having the natural cementation or either we are having the artificial cementation. So this will increase the bonding, and that bonding is due to the calcium carbonate and the iron oxide present in the soil. It will increase the cohesion or the cohesive behavior of the soil. Second, electrostatic forces which can hold these particles together. For example, if you are having two particles, so the electrostatic forces will hold these particles, or the negative charges and the positive charges will hold these particles together. Negative pore water pressure, which we will discuss in the soil tension and in soil suction as well, and we are having a video on it. The negative excess pore water pressure, so when the soils tend to dilate or expand when you shear the specimen, and we will discuss this dilation and expansion in when we go to the topic which is related to the typical response of the soils. Now broadly we can summarize the factors which are influence the shear strength. These are related to the soil composition, and in composition you will have the mineralogy, different types of minerals, grain size. If you're talking about the clay minerals, you will have the grain size, and you will have so what are the different types of clay minerals? What are the different types of clay minerals?
सर, 3 टाइप्स है, नाम मुझे नहीं आते सर, लेकिन वो मुश्किल से नाम है। कुछ गैप्साइड शीट्स हैं, कुछ इस तरह के सर, क्ले
So
मिनरॉलजी में।
we are given with the montmorillonite, kaolinite, and elite. These are the major minerals which are present in the clay soils. Grain sizes, grain size distribution, these affects shape of the particles, pore fluid type which is present in between the soils, particles content and the ions on the grain and in pore fluid. Initial state is also important. For example, if we are preparing a specimen, either it's loose, either it's dense, whether we are taking the OC clay or whether we are taking the normally consolidated clay, whether it's stiff or soft. So these all affect the shear strength of the soil. Now, when it comes to structure, it's the arrangement of the particles within the soil mass, that how you arrange those particles and how these are filling the voids which are present in here. So these are the voids. How, and if, for example, this is a rounded particles, so if we are having rough angular particles, how they are arranged. So it all depends upon the arrangement as well, which will give the strength to the soil. There are a few definitions of the terms, different types of terms which are used below. Shear strength, tau F, effective friction angle, phi prime, cementation, C sub Cm, soil tension, C sub T, cohesion, C sub naught, undrained shear strength, Su, parent cohesion by C. Now, a term will be used in the coming text below. So when we prepare a specimen in direct shear test, and if it's a loose one, it will strain harden. For example, if it's a loose one. Now, if we prepare a specimen, a dense one, it will reach to a state, and that state at which the stress will not change and the strain will increase with the constant shear stress. So the shear stress is constant and the strain is increasing. Sorry, this is the strain. For example, it's the axial strain in percentage. Now, if we want to draw that in terms of, let's suppose we are going for the change in the volume. So for the, you can say the compression is positive here, dilation is negative. So in loose soil, we will be having compression, but in case of the dense soils, we will reach to that same critical state at which we will be having constant volume. So you can clearly see that if you relate these two figures, this is the critical state. We are going in very detail in this topic, but for the time being, we can say that this is the critical state of the soil. Dilation, if the particles are densely packed, then initially for small strains we will be having compression, but after that the soil will dilate or expand. This is known as the dilation. Now, typical response for the over consolidated clay and for the normally consolidated clay. So for example, if we are performing a simple shear test on loose sands or normally consolidated clays, and if we are running the monotonic test, So this is the monotonic or static test. Now in that case, the sample is loose. Therefore, when you are shearing the specimen, there will be change in the height of that specimen. And if you want to measure the axial strain, so you can simply measure the delta Z, which is here, change in the height divided by the H naught, which was here. You can say this one here as well. Now, if you want to measure the shear strain, so the horizontal displacement, which the sample made in the direct simple shear test, and I will explain what is the simple direct shear test. So if delta X divided by H naught, so that will give us the shear strain in this specimen. Now, if we are performing the monotonic test on dense sands and OC clays, then what will happen? Initially, it will compress, but after some time, these particles are densely packed. Therefore, when you started the shearing of this specimen, so they were trying to dilate, or the particles wants to move upward. Now in case of this one, because the particles were loosely prepared, so these particles try to compress, and therefore we will see the change in the height of this specimen. Now, when I was in South Korea at Busan National University, so I was told to perform monotonic and cyclic direct simple shear tests. In order to perform the direct simple shear test or cyclic direct simple shear test, you need to know first how you can perform this test. So for example, this is the motor which apply the shear stress in the monotonic state, or we can also perform the cyclic, which means that we are given with a shear box here which will move in both direction depending upon the stress ratios. A arm is here just to give support to the loading, and here is the load cell, S-shaped load cell. Linear variable transducer is here. Now what else? It's clamped just to hold this arm firmly, and the sample is inside here, which is placed in the wire reinforced membrane. And I will come to the wire reinforced membrane here in this slide. Now, if you are performing the cyclic direct simple shear test or the monotonic direct simple shear test, you need to prepare the specimen, and there are people who are doing research on the wire reinforced membrane and stacked rings. So you can either prepare, you can take a membrane and then you can place those stacked rings around that membrane, which will give the confinement. But there are researchers who thinks that if you place these stacked rings there, what's going to happen, there will be friction between those stacked rings. So in order to avoid those frictional errors there, you need to prepare the sample in the wire reinforced membranes. So this is how I prepared the specimens using the wire reinforced membrane and the stacked rings there in the direct simple shear apparatus when I was studying at Busan National University. So the schematic behind the direct simple shear test is here, that during the consolidation, so these are the wire reinforced membrane and these are stacked rings, and when you go for the shear stage, so this is the consolidation stage, the load is applied on top of this sample. So here is the sample and this is the top cap, this is the bottom pedestal, and these are the stacked rings. Similarly, you can apply that normal load. Now when you are shearing the specimen, basically this motor here is applying load because we connect this shear box to the motor here, so it can move in this direction and it can move in this direction as well, depending upon the monotonic or dynamic or cyclic load which you want to apply onto that specimen. So here you can see that if you need to calibrate first your setup, and that calibration can be done using water only present in this specimen. So if you just put water into, or if you prepare just only water into this membrane, wire reinforced membrane, you place the top cap here and then you will place water inside here, and then you will place the stacked rings around that membrane, and then you will place the top cap, okay, here as well. And once you do that, you can clearly see that a very small amount of horizontal stress, for example in case of rings, so this is the membrane and water is inside there, we are given with the stacked of rings. It's like approximately 25 stacked rings are used, so the height of the specimen is 25 and the load is applied onto the specimen here, and then the wire reinforced membrane, so I would draw something like this. Now in that case, this is the specimen which is H2O. Now we need to test that how much is the resistance or the friction between these stacked rings. So you can clearly see that it slightly increased with the 10% axial strain, and then you can clearly see that it reached to approximately 4 kilopascal. Now that is the error or the friction between one stacked rings and the other stacked rings. So this is the roughness of that stacked rings which are creating a little bit of error. Now when we are dealing with the wire reinforced membrane, so you can clearly see that this gives us a very small amount of horizontal stress, which is almost 0.5 kilopascal. So some researchers, a few researchers say that it's better to use wire reinforced membrane compared to the rings, but Few others says that no, it's better to use the rings instead of the wire reinforced membranes because that it will deform, and that deformation can affect the constant volume state, which is very important in determining the pore water pressure. Now, how the pore water pressure is measured, it's a very interesting apparatus. Now you prepare a specimen inside, and then you apply the initial sigma prime NC, which is the normal consolidation stress. Now, when you are shearing the specimen, and when the sample is sheared, what would happen here? The sample would either compress or it will dilate depending upon the state of the soil. So the interesting thing here is that simple shear apparatus works on the active height control. Now you will fix the height here, but now this sigma prime n will change. Now as this is changing with the shearing, so any decrease in this sigma prime n, for example, if we are having a loose specimen, so what would happen here? It will go down, these particles will go down, and the sigma prime n will reduce. So as this will reduce, so you can clearly see that it started with 0, but if it's reduced, the time will come that it will become 0, and this sigma prime nc or delta u will be equal to this thing. And now the sample will be completely liquefied, or the static liquefaction will occur, or if we are performing that in the dynamic or in cyclic condition, that if we give some certain frequency here, then this soil specimen will liquefy, and this pore water pressure will give us an idea that how this effective stress is affected. So we will come to the effective stress here if the pore water pressure is greater, and this is the sigma prime. I would call that as NC here, just to relate it to the current scenario. So if these both are equal, it means the effective stress equal to 0, which means that the shear strength of the soil is nothing, and it will lead to significant deformation in that soil. Now, if we perform test using rings and using the wire reinforcement, so what would happen here, that with 50 kilopascal of the confining, or we can call it the normal effective stress, so this is the behavior related to the rings, and this is the behavior related to the wire reinforced membrane. So you can clearly see that it gives us the shear stress is plotted on the y-axis, and shear strain is plotted on the x-axis. So if you reach to approximately 25% shear strain, so you will see that the shear stress which is taken by the clay, which was consolidated at 50 kilopascal, which means that this load was 50 kilopascal, and here the shear stress reached at 50 kilopascal of the effective stress is equal to approximately 12 kilopascal. Now when you apply, or when you increase you can see here the sigma prime and C, which is the effective normal stress or the consolidation stress, which is applied similar to the direct shear test. But you can see here that it's a geocomp apparatus, and in geocomp apparatus you don't go for the, let me remove that if I can clearly see that. So instead of putting weights on those hangers as we do at our soil mechanics lab, you just give them a computer control values here, and that computer control will apply automatically the vertical load onto this specimen. So this arm is used just to keep the verticality of the application of the load. So if kind of rod is attached here, there is a rod inside, there is a hole inside in between the arm here, which is attached to this load cell, which measure the normal effective stress here, and any change in this specimen, because that is also measured by the load cell, and then you can relate that to the sigma minus U, or the pore water pressure. So that's how you can increase the loads on top of the specimen there. And now if you prepare another specimen, then you will perform a test on the rings and also the wire reinforced membrane. Generally, wire reinforced membranes slightly gives a slightly weaker response compared to the uh, stacked rings, because stacked rings are a bit more stiffer than the copper wires. So therefore you can clearly see that a slightly weaker response is observed in case of the wire reinforced membrane specimen. So these are the tests which were performed on the clay. These are the tests which were performed on the silt. So you can clearly see that the strength of the soil is significantly less than the clay's one. So the strength is greater for the clay soil compared to the silty soil. Now, if we measure the pore water pressure, so you can clearly see here that for the wire reinforced membrane and for the rings, when the sample was consolidated by the 50 kilopascal of the normal effective stress, then you prepare another specimen, two specimen, one for the stacked ring, the another for the wire reinforced membrane, and you can notice down the excess pore water pressure as well by the reduction of the sigma, prime, and C. Okay, now these were discussion which was important because this Budu's book is mainly focusing on the simple direct shear apparatus. So it's important to discuss what is a simple shear apparatus, because if we are going into the details. Now there is another concept which is very important in case of the simple shear. That word simple shear, you can see here. So if we are dealing with the wire reinforced membrane, or if we are dealing with the stacked of rings there, so the sample is sheared at different layers. For example, like this. So instead of a predefined failure plane, and the stack of rings, they are here, so they will shear the specimen at each and every failure plane. So along that height, so approximately we will be getting a uniform kind of failure planes in the short, I guess it was 25 millimeter specimen, and the diameter was 50, sorry, it's 50, 50 millimeter. I don't know why the attendance is quite low today. For him, what's the reason?
सर फजमिल साहब की भी क्लास चल रही है सर, तो कुछ लोग उधर हैं, कुछ लोग इधर हैं सर।
Okay. Now, the famous stress strain behavior, which we discussed in detail in the undergraduate courses, that if we are shearing the specimen, for example, if we plot shear stress, and on the x-axis we plot the shear strain, and if we are shearing the specimen, so in the loose sand or the normally consolidated or the type 1 soil will strain, harden, and then it will reach to the critical state. But in case of the type 2 soils or the dense sand or the over consolidated soils, it will reach to a peak state first, and then it will reach to the critical state. There are other types of soils which will reach to a peak strength, and then it will strain, soften, and due to the alignment of those particles, it will reach to the residual shear strength, which will be less than the critical state strength. Now, if you want to draw the vertical strain, or I would say the volumetric strain, so we can clearly see that there will be compression in case of the type 1 soils, loose sands, or the normally consolidated clays. But as the samples are prepared densely, then it will reduce, and the soil particles will expand, or the soil will dilate, and that dilatancy can be found out using this equation. If you want to draw the void ratio versus shear strain, so for the type 1 soils or the loose sand, or we can say the normally consolidated clays, in that case the soil will compress, and the void ratio here, for example, it was E1, and now we are having E2. E2. So the E2 would be less than E1 during the shearing stage. For example, if you are going with the type 2 soils, so in type 2 soils, initially there will be slight decrease in the void ratio. For example, here it's E3 and here is E4. So the E4 is greater than E3 because it's type 2 soil, which are dilative, which can have the potential to dilate or increase or expand. Now, the critical state shear stress is reached for all soils when no further volume change occurs under the continued shearing. So that is the definition of the critical state. We will use the term critical state to define the stress state reached by a soil with no further change in shear stress, and the volume occurs under the continuous shearing at a constant normal effective stress. If we are dealing with the dense sands or OC clays, then the shear bands will occur, and these shear bands means that particles which are present in these layers or in these bands, they are fully softened or they have reached to the critical state. That's why they will give us lesser strength or even the residual shear strength. However, the soil which is present in between these shear bands, they are rigid, stiff, or dense, or I would say overly consolidated. But in these shear bands, those particles have significantly reduced the strength of that soil. The famous Moore Coulomb space, and what we studied in the undergraduate, that for normally consolidated clays or loose sand, so if we want to plot the Moore Coulomb envelope, so it will give us C equal to 0. But if we want to perform the test on the over consolidated clays, they will give us an intercept of the cohesion. This is the cohesion intercept, and we can extend that something like this, and then you can find out the friction angle. Now that transition is related to the pre-consolidation pressure. There are different types of minerals present, which will give us the different Q prime, which is the deviator stress, versus the P prime, which is the effective confining stress. They will give us these are the ranges for the montmorillonite minerals. These are the ranges given for the elite minerals present in the clays, kaolinite minerals present in the clays, and the quartz sand will show zero cohesion, and this will be the range for the friction angles as well. Is the voice clear and the screen visible?
Yes, sir.
Yes, sir.
Are you getting what I'm trying to explain, or is it going over your heads? फहीम, मुश्किल है आसान है?
बस कुछ मुश्किल है, कुछ आसान है सर।
अच्छा, सुमेर, मुश्किल है कि आसान है?
सर आसान है, इतना मुश्किल नहीं है, लेकिन थोड़ा कंफ्यूजन है ग्राफ वगैरह।
अच्छा, वहीदुल्ला, मुश्किल है या आसान है? किफ़ायत, मुश्किल है या आसान है?
सर 50-50 है, ये ग्राफ थोड़े से वो है, बाकी सही है सर।
अच्छा, और बाकी कौन रह गए? हलीम आया है। हलीम, मुश्किल है या आसान है? Look, the thing is that we explain few things here during the class, and then you understand, for example, 50 to 80%, then you read a little bit again, 2% adds up, then you read a little bit again, and you compare the graphs with the text there, and you get 2%, 5% added, and then you get to the 90 to 95%. So that's why we have written there that a self-study would be important there. Now, if there is a research which is conducted to correlate the friction angle, or simply the sign of the friction angle, with the plasticity index. So if they find out a relation that as the plasticity index of the clays or the fine grained soils increases, the frictional angle will reduce. And why we are studying it? Because friction angle is one of the shear strength parameters which you can correlate with the plasticity index. There is another term which is used in here, which is the activity, and that activity is the water holding capacity of the clay, and the changes in the volume of the clay in soil during the swelling or shrinkage depends upon how active that soil is. Now, when do we use drained shear strength in clays? When to use drained shear strength, when we use undrained shear strength, and why?
सर शॉर्ट टर्म और लॉन्ग टर्म पे अगर हम फाइंड करना चाहते हैं shear strength क्लेस की, तो फिर शॉर्ट टर्म पे करते हैं तो फिर हम सर अनड्रेन करते हैं, और अगर लॉन्ग टर्म पे हम फाइंड करते हैं shear strength तो फिर हम ड्रेन कंडीशन कंसिडर करते हैं।
Anyone else wants to add? Okay, so for the long-term stability of the embankments and slopes it's better to use the drained shear strength. Now, for the long-term stability of the dams and levees, it is better to use the drained shear strength. And shear strength assessment for heavily over consolidated soils must also be done using the drain shear strength of the clays. Now, here is a very important case study which occurred in Jackfield landslide. Henkel and Skempton, which is the Skempton pore pressure parameter, who proposed the B value, Skempton pore water pressure parameter. This is the B value which is used for the saturation check to be done after the saturation stage or back pressure saturation. Anyways, so he was the Skempton. They were performing, they reported in Geotechnique paper that a landslide occurred along the slip surface here. A railroad is present here. A road is present here. And here we are having the Severn Trent or Severn River in UK. Slope inclination was found out to be 10 degrees. Liquid limit, plastic limit, and the water content information was collected from the landslide. It was found out the shear stress or the destabilizing shear stress or the driving shear stress was 400 pound per square feet. The thickness was 17 feet for that slope. Now, this is the cohesion intercept or the effective cohesion they find out for the particular soil which was present in the slope. The friction angle AF is the parameter which is found out using the shearing stage. Now the resisting shear strength of the soil, when you calculate using the cohesion, using the friction angle, and using the effective stresses and the pore water pressure, it will come up to 580 pound per square feet. Now the factor of safety comes 1.45, which is greater than 1. So they got really interested that why this landslide occurred when we are having the factor of safety equal to 1.45. What could be the possible reason? So the factor of safety came to 1, or the slope failed when we take the C prime equal to 0. here, the shear strength of the soil will be 430 psf, and 430 divided by 400 will give us the factor of safety close to 1, which means that you need to consider the possibilities of the clay softening. The clay has softened due to the rainfall, and the shear plane had high moisture content, and that softening occurred, which caused the progressive failure or the slick insides with clays, particularly the over consolidated clays. Now, if you want to find out the undisturbed peak failure envelope, you can find it like this. And if you want to find out the fully softened peak, you can find it like this using the equation where you will take the C equal to 0. But now here C is not equal to 0 in case of the peak failure envelope. This is the softened, and C is equal to 0 in case of the residual as well. Now, in case of the peak failure envelope, the particles are flocculated or interlocked, somewhat like this. But in case of the residual state or the softened state, when it crosses the softened state, at this particular failure or the slip plane, these particles will align, and it will have significantly lower shear strength compared to the flocculated or the interlocked particles. So in over consolidated soils, you will experience peak strength, and these particles are more flocculated. In case of the normally consolidated, you will experience the softened behavior and the particles begin to align. But due to the large strains, this will experience the residual strength and the particles are aligned on the slip surface, as you can see in this figure. Now, the question is which strength we need to pick. Should we go for the peak strength? Should we go for the softened one? Should we go for the... So we are given with these three strengths envelopes. Which one to choose? Which one we need to choose? Halim?
I think, sir, we should go for the peak one.
Why? Why you think that we should go for the peak one?
I don't know. I just guessed that. Sorry, sir.
It's okay, no problem. That's why we are here. Anyone else? Kifayat, which strength we should pick in such cases? Should we go for the peak, softened, residual? Which one?
I think, sir, I will go also with the peak.
That Wahid, which one you will pick? Wahid, which one?
Residual, sir.
Your voice is very low.
Residual, sir.
Why?
Sir, sir, what चीज़ का नहीं पता. I don't know reason.
Okay, okay. Thank you. No problem. Now, there are other factors as well that if the clay size fraction, which passes the number 200 sieve, is less than or equal to 20, or if it's in between, or if it's greater than 50, so that can also affect also limit the as well. The estimation of the residual drained friction angle in clay in between 25 to 25%, and it can also be related to the greater than 50%. Is greater than 50%, very, very low, and again this one less than this one. Now, the answer to the previous question is that use the peak will be unsaturated.
सर आवाज आपकी बहुत
If you're
कट रही है सर, क्लियर नहीं है.
okay, is it not clear?
सर अभी सही है. यस सर.
Is it clear now?
यस सर अभी ठीक है.
Okay, thank you.
Yes,
I
sir.
don't know. Okay. So the soil, if you are sure that the soil will permanently remain unsaturated, now in that condition, we will go for the peak friction angle. But as you know that we don't have any guarantee or surety that this soil will remain unsaturated. Now, if we are dealing with the construction or the temporary facilities which are less than 1 to 2 years, then we can go for the peak friction angle. But if you want to use the softened friction angle, they can be used in dealing with the excavated slopes, long-term stability of any soil slope that could become fully moistened, which will occur in vast majority of the cases. Now, in case of residual friction angle, when very large strains are possibly having a possibility, for example, the slope stability issues. So it's better to use the residual friction angle. Now, when we are dealing with the landslides or earthquake induced displacements, it's better to use the residual friction angle because the earthquake loading will significantly reduce the shear strength of the soils. Now, in cyclic loading, earthquakes, machine foundations, wave induced conditions, the residual friction angle should be used in such analysis. Now, when you want to perform the undrained shear strength of the clays, so you can go back to the concepts which you learned during the undergrad. So you will have the deviator stress versus the axial stress strain curve for the loose or the normally consolidated soil, and for the dense one or the over consolidated clays are OCR greater than 1. And if you draw the shear stress and the normal stress behavior, so you can clearly see that you will see that transition for the pre-consolidation behavior. If you want to plot the Moore Coulomb envelope, it will give us the bilinear curve here. So this one is the normally consolidated clay, this portion, which is the linear having 0 cohesion, and this portion will give us the bilinear part here, which is happening due to the over consolidation of the clays. If you want to draw the pore water pressure versus normally consolidated for the axial strain curve here, this is the pore water pressure and this is the axial strain. So during the shearing, we will have positive pore water pressure, which means the sample is compacting. And if it is over consolidated clay or if it is a dense sand, then initially, because it has already been compacted too much, too dense, so initially there will be a compaction, then we will experience the dilation or the expansion of that soil. If you want to draw the Moore circles, you can draw different Moore circles as well. And in case of the UU test, we already know that it's unconsolidated and drained test. So if you perform the sigma 3, this one is the sigma 3 and this one is the sigma 1. Now if you just increase the sigma 3 and you don't allow the apparatus and the specimen to consolidate, it means the effective stress are not increasing. So in that case, the diameter of the Moore circle will remain the same, which means the shear strength of the soil will remain unchanged and it will remain the same. Now, if on a sample the normal effective stress is increased, how that will affect the soil behavior. So for example, here we are given with the shear stress and shear strain, and this is the sample tested on the loose, I would say loose sand 1, and I will take that, I can leave it like this. Here is the, for example, here is that point, and this is the volumetric behavior because it's consolidated drained test, which means volumetric change will occur this is the specimen 1 and here is the void ratio versus shear strain. So this is sample number 1 for the loose specimen. Now for the loose specimen 2, for example, it's here, and this is the loose specimen 2. And here the loose specimen 2 for type 1 soils or the loose, or I would say normally consolidated clays. Now for the case of, let me take the yellow one now. This is the first sample which is performed onto. So you can say here is the another point, and for the case of the dense specimen, initially it will compress and then it will dilate. Now if we want to draw this using the change in the void ratio versus, this will be the specimen for the lowest effective stress in case of dense specimen. Now if we want to go with the dense specimen and we increase the confining pressure, so this will be increase the peak strength and it will reach to the residual strength. Now you can use another point somewhere here, okay, and as the effective stresses are increasing, so it will reach to this point. This is the second one, and then the third one, and the fourth one for the type 2 soils. And we already know that the type 2 soils are related to dense sands and also overly consolidated clays. Okay, now if we further increase, so I will keep that as the bluish one. So if you further increase the confining pressure on the specimen, it will show the removal of the peak strength which we observed here. Can you see that? You can clearly see that it will try to behave similar to the type 1 soil behavior. However, the increase can be seen here, so you can take another point from here and you can also take another point from here. And if the normal stress is increased, so for this, this and this, you can clearly see that the dilatancy will reduce when for the type 2 soils the increasing normal effective stress is occurring. Or we can say in this figure we can clearly see that with increasing normal effective stress, the dilatancy will significantly reduce with the increase in the normal effective stress. Okay, now what is effective stress?
सर आज के लिए सर काफी नहीं है सर, बहुत ज्यादा हो गया सर.
The rest of the slides are very easy.
Okay, sir.
Yeah, the rest of the slides are very easy. It's related to the undergraduate concept. We will finish at 5:50 p.m. or 5:45 p.m. So we have the time, and the rest of the things are very easy. I can understand that these are advanced concepts which are discussed here. Therefore, some reading is required, but the rest of the slides, I think so it's very easy, very basic. I hope, and we can take a break here for 5 minutes and then we will join again. Okay?
ऐसा में सर हमारे बाकी जो कोर्सेज क्लासेस होती है तो मैक्सिमम 1.5 घंटे या 1 घंटे तक हो जाती है, क्योंकि सर ये बहुत कंटिन्यू होती है ना, तो इस वजह से मतलब काफी काम हो
किन
जाता
किन
है.
टीचर्स की क्लासेस 1 घंटे तक होती हैं?
जी सर, मास्टर्स की हमारी जो क्लासेस हैं मतलब मैक्सिमम 1 घंटा 20 मिनट या 1 घंटा 30 मिनट तक हो जाती है सर.
तो ये बाकी स्टूडेंट्स किधर हैं जब दूसरी क्लास जो है ना वो खत्म है?
आई डोंट नो सर.
नहीं, आज की क्लास थोड़ी सी इंट्रोडक्टरी है, तो उसमें बेसिक कॉन्सेप्ट्स हैं, तो उसको हम थोड़ा बहुत जो है ना एक्सटेंड कर सकते हैं.
ये तो है सर.
वो आगे जो कॉन्सेप्ट्स हैं वो बहुत इजी भी हैं. देखें, वो अंडर ग्रेजुएट स्टूडेंट्स के लिए जो है ना हमने पढ़ाए हुए हैं जियोटेक 2 में, जियोटेक 1 में, तो वो उतने कॉम्प्लिकेटेड नहीं है जितने ये डायलेशन के कॉन्सेप्ट्स हैं या इफेक्ट्स ऑफ, ये थोड़ी सी नई बातें हैं, थोड़ी सी एडवांस्ड बातें हैं। तो जैसे ही आप उसको रीड करेंगे, उन नोट्स को देखेंगे, तो इंशाल्लाह आपको समझ आ जाएगी, और वीडियो को बार बार देखेंगे तो आपको
ओके
समझ आ जाएगी। ठीक है, तो हम 5 मिनट की ब्रेक लेते हैं, और 5 मिनट की ब्रेक के बाद हम आते हैं, हम कोशिश करते हैं कि हम इस लेक्चर को खत्म करें। ठीक है, थैंक यू।
ठीक है सर, थैंक यू सर।
ओके ओके, अल्लाह हाफिज। ओके सुमेर, प्लीज काइंडली वो ग्रुप में, अगर आपके स्टूडेंट्स का कोई अलहदा ग्रुप है तो वहाँ पे आप उसको मैसेज कर लें, क्योंकि इरफान तो कह रहे हैं कि वहाँ पे सिर्फ एक ही स्टूडेंट आया है, बाकी स्टूडेंट तो है ही नहीं वहाँ पे। तो आप किधर जा रहे हैं? ये बाकी किधर गए हैं यार?
सर मैं ग्रुप में लिंक शेयर करता हूँ दोबारा।
हाँ ना यार, काइंडली आप, ये वही लिंक है वैसे, दोबारा रीशेयर कर लें, कुछ वही कोड शेयर कर लें।
बाय द वे सर, आपकी जो मतलब टीचिंग का तरीका है तो एडवांस है सर।
क्या मतलब एडवांस है यार?
नहीं मतलब मतलब बहुत मतलब काफी मतलब चेंज है हमारे जो मतलब नॉर्मली हम पढ़ते आ रहे हैं। तो इंशाल्लाह सर बहुत मजा आएगा इस कोर्स में।
यार हम तो अपनी तरफ से कोशिश ही कर रहे हैं,
जी
और
सर।
कोशिश में जो है ना, हम ये चाह रहे हैं कि आप थोड़ा सा नया सुने, ठीक है,
Yes,
जो
sir.
कि यहाँ पे नहीं पढ़ाया गया, जो चीजें
Yes,
यहाँ
sir.
पे नहीं पढ़ाई गई, तो वो आप लोगों को थोड़ी बहुत एक्सप्लेन करें और उसको जो है ना यहाँ पे लेके आए।
Yes, sir.
तो अगर थोड़ा बहुत आपको मुश्किल लग रहा है,
नहीं sir.
आप मुझसे पूछ सकते हैं एनी टाइम, ठीक है, कोई
जी
मसला
सर,
नहीं है।
जी
और जो भी हो, जिस टाइम पे भी हो, व्हाट्सएप का ग्रुप भी है, कोई क्वेश्चन पूछना चाहते हैं आप लोग, या आप लोगों को कोई चीज समझ नहीं आई, देखिए हमारे पास 2-3 घंटे होते हैं ना, जब तीन
जी सर,
घंटों में हम एक लेक्चर को कोशिश करते हैं कि उसको कवर करें।
जी सर.
तो ये वी विल ट्राई, ठीक है, वी विल ट्राई आवर
हम्म,
बेस्ट, द वे वी कैन कम्युनिकेट। इसीलिए जो है ना हमने एक पैड भी यहाँ पे लिया कि उसमें अगर ड्राइंग्स वगैरह जो है ना हम ड्रा कर सके, आपको अपने जो कॉन्सेप्ट्स हैं वो अच्छे तरीके से ड्रा भी कर सकें, एक्सप्लेन भी कर सकें। फिर भी अगर आपको कोई इश्यूज वगैरह आते हैं या कॉन्सेप्ट की समझ नहीं आती, तो थोड़ी सी सेल्फ स्टडी करें और उसके बाद जो है ना आप मुझसे पूछें, दोस्तों से पूछें, तो
जी
इंशाल्लाह यू विल एंजॉय द कोर्स। एंड मेरी कोशिश ये होगी कि आप कुछ नया सीखें, जो कि आपको जो टेक्निकल इंजीनियरिंग में, अगर आप अल्लाह ताला करे कि अगर आपको फील्ड में जाते हैं या अगर आप बाहर के लिए, तो आपकी बेसिस बनी हुई हो, आपको एडवांस जो कॉन्सेप्ट्स हैं रिलेटेड टू जियो टेक्निकल इंजीनियरिंग वो आते हो, ठीक है।
जी जी सर. Yes sir. Thank you sir.
थैंक यू वेरी मच अली। Okay, we will start the lecture. I don't know, the class has been finished there, and I talked to the teacher there as well. So he said that only one student was present there. So let's see, I have already texted in the class that please join if possible. I have texted again to join into the class. So we will start with the effective stresses. Okay. So I hope the voice is clear and the screen is visible. So we will start with the effective stresses. Now the effective stresses plays an important role in determining the shear strength of the soil. For example, if we are having the soil here, let me change the color.
Sir, our screen show नहीं हो रहा sir.
Okay, let me do that. So is it clear now?
Yes sir.
Okay. This is the soil element having A of A here is the particle and
Sir, आवाज clear नहीं
the
है.
is okay. Is it clear now?
Yes sir, अभी ठीक sir.
Okay. So the load is applied, and if you divide that load by area, we will get the stress. And here is the pore water pressure, which is exerted onto the particles. Okay, it's saturated soil. When the load is applied, the pore water pressure will increase, so U will increase, and when the U will increase, so this will push those particles apart. And through the time, excess pore water pressure will steadily reduces and begin to take some of the load. This is known as sigma prime. So the load taken by these particles is known as the effective stress. Okay, and the equation, which is the famous equation Total stress is equal to sigma prime, the effective stress, plus pore water pressure, or sigma prime is equal to sigma minus U, which is the effective stress is equal to total stress minus the pore water pressure. Now, eventually the excess pore water pressure will reduce to zero and all the load will be taken by these particles and the pore water pressure has been dissipated. Okay. For the effective stresses, let's have the saturated soil. No air exists in the voids. If we zoom into the soil, we can see that there we are having soil particles, and we are also having the pore water present in the soil. Now, if the voids contain only water here, and if we zoom out, now you can clearly see that the vertical load is applied onto the soil, which is saturated, and you can assume that as a foundation base as well. And how you can calculate the stress, this is the load per unit area, and the vertical stress applied to the soil is known as the total stress. So this will be the total stress. Now, the pore water pressure or the excess pore water pressure will increase. Now, after some time, the dissipation will start. Depending upon the permeability, the K parameter, which you remember, you studied the coefficient of permeability. So it's greater for the cohesive soil, and it's low for the, it's greater for the cohesion-less soils like the sands, and it's less in the fine grained soils or clays. We can simply write that as well. Okay, at the end, all the pore water pressure will be dissipated, the volume will reduce, the effective stresses will increase, and these can be represented by the famous equation sigma minus U. For the over consolidation ratio, the effect is, if you want to plot, for example, the shear stress versus shear strain. So for the over consolidation ratio having, for example, 2, over consolidation ratio, for example, see the increase in shear strength of due to the increase in the consolidation ratio. How this will affect, or how the OCR or the over consolidation ratio will affect the volumetric strain behavior. Now the volumetric strain behavior would be somewhat like this for OCR equal to 2, and the dilatancy will increase in case of OCR 4. So as the OCR is increasing, the dilatancy will increase with the increasing OCR, and also the shear strength of the soil will increase with the increasing OCR. There are a few essential points just to revisit all these points there. Effect of drainage of the excess pore water pressure. So if you want to compare the volumetric behavior or the void ratio change behavior here like this, and we want to compare it with the changing with the excess pore water pressure, so we can do that comparison somewhat like this. So for the loose soils, we already know that we will experience compression, and the pore water pressure would also give similar response like the compression behavior here. Now for this is type 1 soils are loose are normally consolidated clays. Now in case of the, let me change the color here so we can go for the bluish one. It's initially compression and then the dilation if we are dealing with the consolidated drain behavior. Now if we are going for the consolidated undrained behavior, there will be initially compression and then dilation, and it will level off. A table is given for different types of conditions and the drained and undrained condition. So excess pore water pressure is 0 in case of drained condition because the excess pore water pressure has been dissipated. But for the undrained condition, it's not 0, could be positive or negative depending upon, it can be positive or negative depending upon the state of the soil. For example, for the loose soil or for the dense soil. Then for the consolidation stage, yes, it is drained. Now in undrained, no consolidation will occur. Now for consolidation for the drained case, yes, it will be drained. Yes, it can consolidate, but the lateral expansion must occur so that the volume change is 0. Basically, the volume change is 0, and in this case, the sample can only experience the change in the lateral dimensions. Okay, so these will change. Overall, the volume A and volume B will remain the same. Design parameters, you can use the effective critical state parameters, effective peak strength parameters, residual parameters, and that prime represents the effective strength of the soil. Okay, and SU is the undrained shear strength of the soil in case of the undrained loading conditions. Now I remember someone told us that the effects of cohesion contains the intermolecular forces. So you already know how the cohesion is generated, soil tension, cementation. So I will explain a little bit about the cohesion. If we are having a water to water bond, that is known as cohesion. And if there is water to solid particle bond, that is known as adhesion. So the effect of soil tension, and there is soil suction there, and that suction can give strength to the soil. So we can clearly see if these particles are close enough. So there will be tension between these water molecules present here, here. So there will be tension, and that tension can cause increase in the strength of the soil or increase in the effective stresses. And if the particles are far enough I would say that in loose state, and this is the dense state. Now, moist tamping technique is used in triaxial apparatus to prepare specimen, and there you will experience these kind of soil suction behavior. YouTube video is highly recommended. It's Professor John Burland, who who is a professor at the Imperial College of London, and also he has worked significantly on the settlement behavior of the famous Leaning Tower of Pisa. So a video you can also watch, the link is there. Now, and I will also share at the end of this lecture as well. Okay, now the cohesion, which is the C cohesion intercept, contains the cohesion due to the cementation, cohesion due to the suction, and the cohesion due to the intermolecular attraction. So that will give us the total cohesion to the soil. Now the effect of cementation is there. Definitely, if these are the particles which we took using the SEM analysis, this is the SEM, or the scanning electron microscopy. Okay, now if you closely see these sand particles, you can clearly see the angularity, the roughness there as well. You can, if you zoom into the particles, the individual particles, you can clearly see that it is very, very rough, and that gives strength to the soil, or the frictional angle as well. See the Toyota sand which I used during my PhD thesis. Here you can clearly see the cementitious bonds which are bonding these particles. So you can clearly see these are the bonds which are created between the particles. These are the particles, the bigger particles, and here we can clearly see that cementitious materials are bonding these particles. I used fibers in my PhD research, and you can clearly see that these particles are bonded with each other, having the cementitious bonds here. Now, why cementitious bonds increase the cohesion, or the cohesion of the soil? How and why? If we are given with the two particles, why the bonding is increased or the cohesion is increased? What's the reactions? What's the phenomena which is occurring there? Between the particles. So basically it is the hydration which is occurring, and that cement hydration will cause the ettringite formations. These are the needle shaped structures which can bond those particles. Essential points are summarized below these topics. Thank you so much for listening very patiently and for your kind participation. Now I will show you a short video that is related to the soil suction and the strength of the soil, and then we will end our today's lecture. Is the screen visible and can you hear the voice of the Professor John Burland? Please confirm.
आवाज नहीं आ रही सर।
ओके, आवाज नहीं आ रही है तो मैं थोड़ा बहुत एक्सप्लेन करता हूँ और लिंक जो है ना वहां पे मौजूद है, ठीक है?
ठीक है सर।
अभी आ रही है?
नो सर।
चलें फिर मैं कोशिश करता हूँ, थोड़ा सा इसको इंक्रीज करता हूँ। अभी
नहीं सर, अभी भी नहीं आ रही।
चलें मैं इसको म्यूट करता हूँ, आपको बताता हूँ कि वाटर प्रेशर का बात कर रहा है कि पोर वाटर प्रेशर और वाटर प्रेशर बहुत इंपॉर्टेंट होता है, ठीक है? पीछे इसके ट्राइजल की अप्रेंटिसेस पड़ी हुई हैं, ये सारी कह रहे हैं कि लैंडस्लाइड हुआ यहाँ पे, डिजास्टर यहाँ पे क्रिएट हो गया था और बहुत सारे लोगों को जो है ना इसने इस विलेज को जो है ना वो तबाह बर्बाद कर दिया था। 166 है कि 116 116 जो है ना वो बच्चों को जो है ना उन्होंने मार दिया था और कुछ 25-30 जो है ना वो बंदे भी एडल्ट भी जो है ना वो मर गए थे। अब कहते हैं कि पोर वाटर प्रेशर कैसे अफेक्ट करता है, अभी आपको ये दिखाएगा। ये आपको खुद सिर्फ एक्सप्लेनेटरी है कि ये कैसे जो है ना वो स्ट्रेंथ जो है ना वो रिड्यूस हो जाएगी। सिंपल ग्लास लिया हुआ है, डिस्पोजेबल ग्लास है। पहला ग्लास जो है ना वो स्लाइड नहीं कर रहा था और दूसरा स्लाइड कर रहा है। अब वो कह रहे हैं कि क्यों हो रहा है ये, दोबारा देखें अभी इसको। कहते हैं कि पहला ग्लास स्लाइड नहीं कर रहा था और अभी दूसरा स्लाइड कर रहा है। इस बीकर के नीचे जो है ना इन्होंने हॉल किया था। देखें कि पोर जो है ना वो वाटर नीचे जाता है और वो एक प्रेशर एक्सर्ट करता है और जो प्रेशर एक्सर्ट होता है तो वो जो इफेक्टिव स्ट्रेसेस हैं वो रिड्यूस कर देता है। कॉन्टैक्ट फोर्स जो है ना वो रिड्यूस हो जाता है और जो शेयरिंग रेजिस्टेंस है वो कम हो जाती है और दैट्स व्हाई जो है ना वो स्लाइड करता है कंपेयर टू द प्रीवियस वन। ये सॉइल की सरफेस टेंशन और शेयर स्ट्रेंथ के बारे में भी बताएगा। कहते हैं हम जब बच्चे थे तो हम सैंड कैसल्स बनाते थे, छोटे छोटे घर बनाते थे जहां पे सैंड मिलती थी। 3 सैंड कैसल्स बनाएंगे हम, एक में पानी बिल्कुल नहीं होगा, सैंड जो है ना वो ड्राई है और हमें एक शेप मिल जाएगी। दूसरा एक डैम्प सैंड से हम जो है ना एक कैसल बनाएंगे। ये भी डैम्प सैंड से ही बना है, मॉइस्ट सैंड हम उसको कह सकते हैं, दोनों मॉइस्ट सैंड। अभी ये सरफेस टेंशन की वजह से स्टेबल है, आप देख सकते हैं कि सैंपल जो है ना वो खड़े हैं, लेकिन पानी जब ऐड करते हैं तो ये सारी सरफेस टेंशन खत्म हो जाती है और ये जो सैंपल है ये फेल्ड हो जाता है क्योंकि पानी इसमें बहुत ज्यादा हो जाता है। कहते हैं कि ड्राई को भी हमें समझ आती है और जब ज्यादा पानी होता है उसकी भी हमें समझ आती है, लेकिन दरमियान में जो सरफेस टेंशन का फिनोमेना है उसकी हमें समझ ज्यादा नहीं आती है, वो अभी एक्सप्लेन करेगा। जो इफेक्टिव स्ट्रेसेस के साथ कॉन्सेप्ट था, कहते हैं कि ये इसलिए पानी ज्यादा हो गया, पोर वाटर प्रेशर ज्यादा हो गया, इफेक्टिव स्ट्रेस कम हो गया, तो shear स्ट्रेंथ बहुत कम हो गई। ये क्यों खड़ा है कहते हैं। अभी यहाँ पे सरफेस टेंशन के कॉन्सेप्ट को समझना पड़ेगा। कहते हैं ये हमारे पास दो पार्टिकल्स हैं, यहाँ पे थोड़ा सा पानी है, ये सरफेस टेंशन में एक दूसरे को जो है ना वो खींच रहे हैं, तो इसलिए यहाँ पे कुछ स्ट्रेंथ इंक्रीज हो जाती है, ये shear स्ट्रेंथ को फिर इंक्रीज करता है। इसलिए ये जो कैसल है या ये जो ग्लास ऑफ सैंड है, मोइस्ट सैंड है, ये स्टेबल है। ये अगर मॉइस्ट कंडीशन में होता है तो फिर कहते हैं shear स्ट्रेंथ को इंक्रीज करता है, और अगर बहुत ज्यादा क्वांटिटी में वाटर जो है ना मौजूद होता है तो वो shear स्ट्रेंथ को रिड्यूस करता है। थैंक यू वेरी मच फॉर लिसनिंग एंड वाचिंग वेरी पेशेंटली, and if you have any question you can ask the question, and I will take the attendance right now. Let me see who is present today. So Kifayat is present.
Yes, sir.
Okay, Rifat is present. Wahid is present. Anyone else? Only three. Okay. Okay, thank you very much. If you have any question, you can ask the question. If you don't have any question, you can write P in the chat box so that I can note down your attendance. Has already been noted down, but you can write P in the chat box just for the record.
सर एक क्वेश्चन है।
Yes, please.
सर ये एक्सिस पोर वाटर प्रेशर और पोर वाटर प्रेशर में एग्जैक्ट क्या डिफरेंस है सर?
एक्सीलेंट, ये बहुत ही बेसिक फंडामेंटल जो है ना वो पॉइंट है। देखें, जब हम एक, चलो मैं यहां से ड्रा करता हूँ।
सर ये चैट बॉक्स कहाँ पे है? ये चैट बॉक्स क्या बात कर रहे थे सर?
बस छोड़ दे, ठीक है, कोई मसला नहीं है। 3 स्टूडेंट तो हैं, वो मैं अंडरग्रेड के लिए वैसे अनाउंसमेंट करता हूं, तो वो मेरी आदत यहाँ पे बन गई है। देखिए यहाँ पे क्वेश्चन किफायत ने किया था ना। किफायत, ये हमारे पास फॉर एग्जांपल सैचुरेटेड सैंड है, ठीक है, इसका वाटर टेबल फॉर एग्जांपल यहाँ पे है। अभी इसके ऊपर यहाँ पे हमारे पास कुछ पोर वाटर प्रेशर तो मौजूद है ना, तो इसको हम क्या कहते हैं? स्टैटिक पोर वाटर प्रेशर। एग्री?
यस सर।
अब जब हम यहाँ पे एक बिल्डिंग खड़ी करते हैं इस सोइल के ऊपर, तो अब क्या होगा? डेल्टा सिग्मा आ गया, ठीक है। अब डेल्टा सिग्मा के साथ क्या होगा? डेल्टा सिग्मा के साथ ये होगा कि यहां पे हमारे पास पोर वाटर प्रेशर क्या होगा? चेंज होगा, इंक्रीज होगा। तो ये जो है ना हमारे पास, इसको हम क्या कहते हैं? एक्सेस वाटर प्रेशर। या अगर हम एक स्पेसिमेन बनाते हैं और उसको हम कंप्लीटली सैचुरेट करते हैं, और उसके जब कंप्लीटली सैचुरेट करते हैं तो इनिशियली हमारे पास यहाँ पे यू स्टैटिक होगा, लेकिन जब हम उसको शेयर करते हैं मोनोटोनिकली या हम उसको शेयर करते हैं साइक्लिकली, तो वो जो चेंज इन पोर वाटर प्रेशर होगा ड्यू टू लोडिंग, उसको हम क्या कहते हैं? एक्सेस पोर वाटर प्रेशर। आइए समझ थोड़ी बहुत।
जी सर, मींस जो स्टैटिक पोर वाटर प्रेशर है उसको हम सिंपल पोर वाटर प्रेशर कहेंगे, और जो लोडिंग की वजह से होता है उसको हम एक्सेस पोर वाटर प्रेशर कहेंगे।
एग्जैक्टली दैट इज एक्सेस। ओके, लोडिंग की वजह से कह सकते हैं आप, ठीक है, एक्सेस पोर वाटर प्रेशर।
ओके सर, थैंक यू सो मच सर, थैंक यू सो मच सर।
वेलकम, अपना ख्याल रखें, अल्लाह हाफिज। यू कैन लीव द क्लास।
ओके सर, थैंक यू।